Alright, C Block, how are you? This is a video for the standard UBFM3, which reads, I can solve problems with Newton's second law, which is F equals ma, or force equals mass times acceleration. This question that we're about to do comes from the quiz on 4/11/19, so get that out to follow along. Alright, so the first thing that we actually have to do is we need to make a free body diagram so that we can make some sense of what's going on. This was also the B question, UBFM2, my free body diagrams look qualitatively accurate. I'm not going to talk about that too much because almost everybody got this right, about 3/4 of the class. But I'm going to do one here anyway, although I don't have a grid on my whiteboard, of course. Okay, so we have some given information. Force of gravity is 3 newtons, obviously down. The normal force is 3 newtons going up, which means that our box is not falling. It's not rising or anything. It's sitting there. We have an Fpush, a force of a push of 2 newtons. That's to the right. And then we have a force of tension, so it's also being dragged, 1 newton, also to the right. Those two forces are going to combine. I saw some people on the quiz draw those arrows in opposite directions, but they are both right and they combine. They're not fighting each other. They are cooperating. And then for the C question, which is what this video is really supposed to be about, is the mass is 10 kilograms. So first of all, here's my box. And I've got 3 newtons going up. I've got 3 newtons going down, and I've got 2 plus 1 equals 3 newtons to the right. I'm going to make that arrow look just about the same size as the other arrows. It's okay if you drew a 2 newton arrow and a 1 newton arrow as long as they were both pointing right. If you are somebody who gets your right confused with your left, I also gave you credit for that as long as the arrows were both pointing left and you didn't have one pointing right and one pointing left. Alright then, so now that we've got that sorted out, we can see that our net force, we've got no net force going up and down, because the 3 newtons up and down balance each other, so we have this unbalanced force of 3 newtons, which means that our box is actually moving, and that's 3 newtons to the right, so you need that in order to solve question C. Alright, so now, force equals mass times acceleration. We have that here. Let's make a triangle. F, M, A. And just to check to make sure I did it right, we know that F equals ma from up there. And if I cover the F up with my thumb, I find that it equals m times a. So I know that I did my triangle right. Alright, so now what we want to do is we want to find the acceleration of the box if it has a mass of 10 kilograms. So we want to rearrange this to say A equals F over M. Right? So if we cover up A, we see that F is over M. So A equals F over M. We know that our net force is 3 newtons to the right. We know that our mass, which is given, is 10 kilograms. And 3/10, if you punch that into your calculator, is going to be 0.3, repeating. And it's going to be meters per second squared. So every second it's going to be going 0.3 meters per second faster than it was the last second. And that's how you do problem C, UBFM3. I can solve problems with Newton's second law, F equals ma.